everyone. In today's lesson, we're going to cover section 5.3, congruent angles associated with parallel lines. After studying this section, you'll be able to apply the parallel postulate, identify the pairs of angles formed by transversal cutting parallel lines, and apply 6 theorems about parallel lines. First, the parallel postulate. In this section, we shall show that the converses of many of the theorems in section 5.2 are also true. Now, a fundamental postulate for parallel lines in the plane is the parallel postulate, and we'll use this postulate for our crook problems. So through a point not on a line, there's exactly one parallel to the given line. So if I have any line, and then I have a point that's not on this line, there's only one line that will go through this point that I drew that's parallel to my line above. Any other line will not be parallel because it will be touching my top line somewhere in my plane. So again, the parallel postulate through a point not on a line, there's exactly one parallel to the given line. Looking at angles formed when parallel lines are cut by a transversal. So in our last section, section 5.2, we learned that depending on the angle relationship and whether the angles were congruent or supplementary, we could show that our lines were parallel. So if I had two lines that were cut by a transversal, if alternate interior, alternate exterior, or corresponding angles were congruent, then I would have parallel lines. If same side interior angles or same side exterior angles were sup, then I would have parallel lines. And if I had two lines that were perpendicular to a third line, then the lines would be parallel. Now the converse of all of these theorems is also true. So if we have parallel lines, then alternate interior angles are congruent. So if I want to use this in a proof, I can say if parallel lines, then alternate interior angles are congruent. Now angles formed by a transversal. So if I cut two lines by a transversal and those lines are parallel, then any pair of the angles formed will either be congruent or supplementary. Now looking at our 6 theorems about parallel lines. So if two parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. So if parallel lines, then alternate exterior angles are congruent. Remember, there's two pairs of alternate exterior angles. If two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. So if parallel lines, then corresponding angles congruent. Remember, there's 4 pairs of corresponding angles. If two parallel lines are cut by a transversal, then each pair of interior angles on the same side of the transversal are sup. So remember, there's 2 pairs of same side interior angles that are sup. Then if two parallel lines are cut by a transversal, each pair of exterior angles on the same side of the transversal are sup. Remember, there's 2 pairs of same side exterior angles. If a line is perpendicular to one of 2 parallel lines, then it's perpendicular to the other. So in my diagram, I have lines A and B parallel to each other, and line C, the transversal, is perpendicular to line A. Therefore, it will be perpendicular to line B as well. Now looking at my last theorem, if we have two lines that are parallel to a third line, then they are all parallel to each other. This is the transitive property of parallel lines. So if line A is parallel to line B, and line B is parallel to line C, then line A will be parallel to line C. To summarize, if we have two parallel lines cut by a transversal, then each pair of alternate interior angles are congruent, each pair of alternate exterior angles are congruent, each pair of corresponding angles are congruent, each pair of interior angles on the same side of the transversal are sup, and each pair of exterior angles on the same side of the transversal are sup. Looking at our sample problems, if we have line C parallel to line D, we want to find the measure of angle 1. So if C is parallel to D, then 3x plus 5 and 2x plus 10 will be equal because those are alternate interior angles. So 3x plus 5 equals 2x plus 10. I'll subtract 2x and subtract 5, which will give me x is equal to 5. Now that I know x is equal to 5, that would tell me both of the angles are 20 degrees. Notice angle 1 and my 3x plus 5 angle are vertical angles, making angle 1 20 degrees, because I know vertical angles are congruent. In problem 2, I have the following givens. I want to prove that angle F is congruent to angle E. Looking at our first given, we have line FA is parallel to line DE. Now, if line FA were parallel to line DE, then I know angle A here and angle D here are congruent because those are alternate interior angles. And if I have parallel lines, then alternate interior angles are congruent. Then I have FA is congruent to DE, and then AB is congruent to CD. Notice I have line segment BC here, so if I add line segment BC to AB and CD, it'll get me line segment AC congruent to line segment DB. Now I can have my triangles, triangle FAC and triangle EDB congruent by side angle side. If those two triangles are congruent, then I can say that angle F and angle E are congruent by CPCTC. So listing out my statements and my reasons, I'd have my first givens, line FA is parallel to line DE. Angle A is congruent to angle D because if I have parallel lines, then alternate interior angles are congruent. Then FA was congruent to DE. Then AB congruent to CD. Then I added BC to these two segments, making AC congruent to CD. Then my triangles were congruent by side angle side. Then angle F was congruent to angle E by CPCTC. Looking at problem 3, we're given that line G is parallel to line H. I want to prove angle 1 is sup to angle 2. So if I have G parallel to H, then I know angle 1 will be congruent to angle 3 because alternate exterior angles are congruent. I know angle 2 and angle 3 are sup because they form a straight angle. Therefore, angle 1 would be sup to angle 2 by substitution. So looking at these in my statements and reasons, I have my first given, G is parallel to H. Then I could say that 2 is sup to 3 if two angles form a straight angle, assume from diagram, they're sup. Then 1 would be congruent to 3 because parallel lines, then alternate exterior angles are congruent. Then I'll show that angle 1 is sup to angle 2 by substitution. Now looking at our last problem, problem 4, a crook problem. If A is parallel to B, I want to find the measure of angle 1. Notice my segment in the middle here is not a transversal, but if I draw a line through point C that is parallel to A and B, thanks to my parallel postulate, now I have this line being a transversal and this line being a transversal of this new line, let's call it M, of MA and MB, which will give me different angle relationships. I will have alternate interior angles for this angle and angle 40, making this angle 40 degrees. And then I would have same side interior angles for this angle and this angle here. These are not congruent, I'm just using the tick marks to show the angle that I'm talking about. So now the angle that I created would be 80 degrees. Now 80 degrees and 40 degrees would make 120 degrees, so angle 1 is equal to 120 degrees.